Hello, and welcome to this presentation on Chapter 4, Hardware, Software and Mobile Systems. In the next three modules, we will focus on IT, which, as you will recall from Chapter 1, refers to the computer-related components of an information system, namely hardware, software and data. In this module, we will focus on hardware and software. The objectives of this presentation are for you to become able to describe the main hardware components, describe the different types of hardware and software, describe the concept of virtualization and cloud computing, and discuss the impact of new hardware and software on competitive strategies for a company. Hardware are the electronic components that input, process, output, and store data according to instructions encoded in software. As you will see from this definition, hardware and software go together. Without software, hardware is just a set of expensive equipment sitting in a corner, and without hardware, software would not be able to do anything. Hardware consists of a set of components. Perhaps the most important is the CPU, the central processing unit, also called the brain of the computer. It consists of one or more processors which are responsible for doing things, and main memory. Main memory is used to store the instructions that the processor will follow and the data that the processor is currently working on. And access to main memory is therefore very fast. There are two types of main memory: ROM, read-only memory, and RAM, random access memory. ROM is typically used to store the central components of an operating system, a type of software we will discuss later. RAM is typically used to store the programs and the data the CPU is currently working on. Unlike ROM, RAM is volatile, which means that if the CPU loses power, everything that is stored in RAM disappears. Storage, on the other hand, is permanent. There are many different types of storage, including hard disks, magnetic tapes, and solid-state storage, typically used in smartphones and tablets. As you probably know, when you're working on a document and you save it, you transfer the contents of RAM to permanent storage. Whether data is stored in main memory or in external storage, the basic way of storing data into today's hardware is in bits. The textbook explains what bits are. It also discusses how you can measure the capacity of a storage device and the speed of a processor. In addition to CPUs and storage, hardware also consists of input devices and output devices. As the name implies, input devices are devices that gather data to be used by the CPU. Examples include keyboards, scanners, and so on. Output devices output data, and examples include screens and printers. There are many different types of hardware, and there are many ways to classify hardware. One distinction is between personal computers, such as desktop computers and laptops, mobile devices, such as tablets and smartphones, and servers. Servers are usually larger computers that receive requests from so-called clients and send data or applications back. A good example is a web server, which receives requests from a web page from a browser running on a client, and then sends the web page to the client for the browser to display. You can make a distinction between thick clients and thin clients. Unlike thick clients, thin clients do not have any external storage, and therefore can only run applications if they are connected via a network to a server. As said, software goes hand in hand with hardware. Again, there are many different types of software, and the primary distinction is between operating systems and application software. Operating systems control the hardware resources, and the most important examples are Windows, Mac OS, and Linux. Application software does things that are useful to a user. Again, you can distinguish between different types of application software. Horizontal market software serves the needs of users across a range of industries. Microsoft Office is a good example. Vertical software serves the needs of users in a specific industry. An example is Autodesk, software that is used by architects and construction managers. Finally, there's one-of-a-kind software, also called bespoke software, that serves the specific needs of a single client. An example might be the software used to control a Boeing airplane. A special type of software is firmware. Firmware that is software that is stored in some special memory, typically ROM, of a device such as a printer. When you update, for example, your printer, you typically download a software patch from the internet, which is then installed in the ROM of that printer, hence making it part of the printer's firmware and making it permanent. Just as there are different types of software, there are different strategies an organization can adopt when it comes to acquiring software. One option is to buy an off-the-shelf software package and use it without any modifications. This is typically how Microsoft Office is used. Or they can buy an off-the-shelf piece of software and then customize it before using it. For example, most universities use Banner to manage student data, but most make some changes to it before they use it to reflect their own specific needs. Finally, an organization can develop, or more often ask a software development company to develop a bespoke application. There are many trade-offs to consider when choosing which strategy to use, but these are beyond the scope of this course. Another distinction you can make when it comes to software is between open source and licensed software. Open source software is developed by volunteers, which means that the source code, i.e. the actual more or less human readable form of the software, can be modified by anyone. Examples are Linux, the operating system we mentioned earlier, Apache, software used to run web servers, and OpenOffice, an open source alternative to Microsoft Office. Open source is often free when you acquire it. Licensed software, on the other hand, requires you to buy a license from the software company before you can use it. Examples are Microsoft Office and Canvas. Again, there are many trade-offs to consider when you decide whether to use open source or licensed software. Typically, open source software is cheaper to acquire, but may cost more to maintain. The textbook has a good discussion on open source software. The final hardware-related concept we need to cover is virtualization and cloud computing. Virtualization essentially means that you get one computer to take on the appearance and act as another computer. For example, you can install software on a PC that, if you run it, makes the PC appear as if it was a Mac. Perhaps the most radical form of virtualization is cloud computing, in which you access a server through a web browser to access data and run applications. If you took CGS 2100, you're familiar with the concept. We will cover cloud computing in great detail in Module 6. But if you are a Mac user, you will start using a virtual machine in the next module. And if you are a PC user, you will start using a virtual machine in Module 9. Finally, new developments in hardware and software often have the potential to create a source of new competitive advantage for an organization or to undermine its position. For example, you could argue that Uber was made possible because of the development of the smartphone, and that the emergence of tablets and e-readers such as Kindle has threatened and continues to threaten the printing industry. The book mentions other technology trends that may undermine existing businesses. While it is of course difficult to predict the future, it's important that an organization is constantly on the lookout for developments that may either threaten their competitive position or may open up new opportunities for them. The Tech News exercise that you're asked to do as part of this course is one way of doing so. And this concludes the current lecture. Please read Chapter 4 in the textbook, and if you have any questions, contact me. Thank you.